like me, you love both science and aerial silks. You might not think these two things have much in common, but in actuality, aerial silks relates to physics, chemistry, and biology. Today I'll find out how these relate to chemistry. The fabric used to make aerial silks is called nylon, and polymerization is the process needed to synthesize this material. You might be wondering, what is polymerization? In general, polymerization is the mechanism used to combine monomers, which are small single units, into a long-chain polymer. To differentiate from polymers and monomers, just remember that in Greek, poly means many and mono means one. Monomers can be a multitude of molecules that all create different polymers when combined. Look at this nylon polymer, for example. Notice how it's made up of repeated units throughout? These are the monomers that make up the long-chain polymer. Another example would be polyethylene, which is a polymer that makes up plastics. The repeated units in polyethylene, or the monomers, are called ethene. Do you think polymerization and chemistry sound boring? Well, let's head to the lab and I'll prove you wrong. I'll be reacting adipoyl chloride hexane solution with hexamethylene diamine sodium hydroxide solution. This is the polymerization reaction used to create nylon. I'll first add the hexamethylene diamine solution since it is the denser of the two solutions. Then I'll add the adipoyl chloride hexane solution, and since it is less dense, it will float on top of the other solution. This will create a two-layer mixture. It's between these two layers that nylon is synthesized. Pretty cool, huh? But how does polymerization do this? Well, to find out, we must look at the mechanism behind polymerization. There are two types of polymerizations. Polyethylene is an example of an addition polymerization. An addition polymerization reaction starts with initiation, where a bond breaks by homolytic fission, leaving a free radical molecule. Free radicals are highly reactive and will react with other monomers in a step called propagation. This step grows and grows the chain. The polymerization reaction is over when a termination step is reached. This is when two free radicals react together to form a stable polymer. The other type of polymerization is a condensation polymerization, which is what is used to create nylon. In this example, adipoyl chloride reacts with hexamethylene diamine. Let's simplify these molecules by replacing their carbon backbones with a blue line. When a condensation polymerization reaction occurs, the reaction releases a small compound, usually water. In this case, since we are using an acid chloride, hydrochloric acid will be released as a byproduct, in addition to forming the polymer. Thanks to this polymerization, we have nylon. If you're not an aerialist, you might be wondering why polymerization is important. Polymerization provides everyday items such as paints, glues, and Teflon-coated cookware. In addition, important items such as silicone heart valves and bulletproof vests. As you can see, polymerization is responsible for a lot of the things in our modern world. Look around yourself. A lot of the things around you are probably present because of polymerization.